Hello class, in this lesson we're going to learn about the side angle side and the side criteria for similar triangles. In this example, I want to show that the smaller triangle, ABC, is similar to larger triangle AB', C'. What do we know from this diagram? Well, we know that they have an angle in common, that angle A, and we also know information about the side lengths. So how is that going to be useful? What can we do to check if these triangles are indeed similar? Well, if we check to see if the side lengths are proportional, then the corresponding side lengths are proportional, then we can see if we have a similarity there, because we know that has to be true if we have similar triangles. So if we check the corresponding side lengths, we were looking at, let's see, 4 to 13, the whole side, and 3 to 9.75, that whole side. And you know, if we're checking for a side splitter, you could have also just compared 4 to 9 and 3 to 6.75. It's really a matter of taste with how you do it, but you will get the same conclusion no matter how you do it. If we check with cross product here, they're equal, so we know the side lengths are proportional. And how does that help us? We only know, if we're using measurements, that triangles are similar by angle. Well, we know that if BC cuts the sides of the triangles proportionally, then by the side splitter theorem, it has to be parallel to B', C'. And when we have parallel lines or parallel segments, we know that those corresponding angles are congruent. So we really do have angle. So that's how that's helpful. So now we are definitely 100% sure that we have similar triangles. Same idea here. We have similar information. We have an angle in common, and we have information about the sides. So we want to check if the QR cuts the sides proportionally. So first two parts here are the same as the previous one. And so now it's a matter of checking those corresponding side lengths. So we could look at 3 to 13, 2 to 9. Are those two ratios equal? No. You cross product and those are not the same number. So the side lengths aren't proportional. So you know that QR is not parallel to Q', R' by side splitter theorem. So those corresponding angles are not congruent. So we can't use the same reasoning as we did in the previous problem. So the side lengths aren't proportional, so that would have to be true if we did have similar triangles. So this gives us the side angle side criterion for similar triangles. So they're similar if you have a pair of corresponding angles that are congruent and the sides that form those angles or are adjacent to them are proportional in length. And why is that true? Well, if we dilate, let's say triangle ABC, using scale factor R, so that it gets, when it's dilated, it's the same size as triangle A', B', C', then we'll have side angle side from congruence, because we know the corresponding side lengths will be congruent, as will the included angle. So since there's a similarity transformation that maps one to the other, those triangles are similar. So in figure 2, we saw that the side lengths were not proportional, so we can't use side angle side there. So this side angle side, now we're talking about side angle side from the standpoint of similarity, so the corresponding side lengths have to be proportional, not congruent, or equal measurements. So we can use that to show if triangles are similar. About figure 3, what information do we have here? All we have is information about the side lengths. And how's that going to be useful? Well, once again, let's check those corresponding side lengths and see if they're proportional. Because you know that has to be true if the triangles are similar. So what do we get when we compare all of the corresponding side lengths? So it looks like we gotta turn this around so that A' ends up with A. And so if you set them up correctly, you should get a proportion that looks something like this. And it turns out that each of these ratios equals 1/2. Or if you did it the other way, you get 2. Take all the reciprocals. So what can we say about the relationship between those two triangles? We think they're similar because the side lengths are proportional. And you need that when you have similar triangles. How about this example? What do they give us? They give us side lengths once again. And so we want to check for proportionality. So when we set up that proportion, so A and B are the same as before. What proportion can we write? Let's go back up here, try to write that proportion, and let's see if it works out. So we'd have to get the same ratio 3 times, but it turns out these 3 are not equal. If you use decimal approximations, these are numbers, the decimal numbers that you get. And so the side lengths are not proportional. All 3 of them would have to be equal. So what can you say about the triangles? They're not similar. The side lengths would have to be proportional. So this gives us the side-side-side criterion. So if all 3 corresponding side lengths are proportional, then the triangles are similar. And the proof of that is similar to what we did before. We would do a dilation with a scale factor that will make triangle ABC the same size as triangle A prime, B prime, C prime. And then you know that those 2 triangles are congruent by side, side, side. And so we have a similarity transformation that'll map one to the other. So the triangles are similar. So in 4, we did not have side lengths that were proportional. So we know that those triangles are not similar. So we can use side, side, side to check for similarity. In this lesson, we learned about the side angle side and the side 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 criteria for similar triangles. There's a little recap of that, with in addition angles on there. So thank you for watching this video.